The new 3-eye atlas image wasn't supposed to look like this. Not smooth, not symmetrical, but alive. Light pulsed through its shadow like a heartbeat in the dark, and for the first time, astronomers began to whisper that something had changed. The photograph arrived at 3:47 in the morning, transmitted from the Hubble Space Telescope through channels that had been open for decades. Channels that had carried 1,000 images of distant galaxies and dying stars, but nothing quite like this. The principal investigator, a woman who had spent 18 years studying cometary nuclei and had seen every variation of ice and rock that the solar system could offer, stood in the control room with her coffee growing cold in her hand and said nothing for 7 minutes. The image showed a kernel of darkness, approximately 400 meters across, tumbling through the space between Mars and Jupiter. But around that darkness was something unprecedented. A corona of light that seemed to breathe, that seemed to expand and contract with a rhythm that made no sense. According to any model of sublimation or outgassing, a rhythm that looked disturbingly, impossibly biological, as if something ancient and patient was waking up after a journey that had lasted longer than human civilization, longer than human existence, longer perhaps than the Earth itself, had been a world capable of asking questions about the things that fall through its sky. The light was wrong. That was the first thing they noticed, the thing that made the data analysts stop their usual morning routines and gather around the monitors in clusters of worried silence. Comets glow because the sun heats their surfaces, because frozen volatiles trapped for billions of years in the deep cold suddenly remember what warmth means and burst outward in jets of gas and dust, creating those magnificent tails that have terrified and inspired humanity since the first human looked up and wondered what those fuzzy stars might mean. But 3-eye divided by Atlas wasn't near enough to the sun for that kind of activity. Not yet. Not for another 6 weeks at least, according to every calculation, every thermal model, every piece of software that had successfully predicted the behavior of hundreds of other comets. And yet here it was, glowing like something that had found its own internal source of energy, radiating in wavelengths that suggested not simple reflected sunlight but something more complex, something that made the spectroscopists pull up their chairs and start running analyses that would take days to complete, analyses that would eventually show emission lines that didn't match any known comet, that suggested the presence of molecules that shouldn't exist in the frozen detritus of stellar formation, organic compounds of such complexity that their presence demanded explanations that no one wanted to be the first to voice out loud. The observatory director made the call to keep the image restricted for 48 hours, not because of any conspiracy or cover-up, but simply because they needed time to verify what they were seeing, to rule out instrumental artifacts or processing errors, to make absolutely certain that this wasn't some glitch in the camera or some contamination in the data pipeline, because the alternative was too strange to announce without being absolutely sure. Those 48 hours felt like 48 years to the dozen people who had clearance to see the raw data. They ran every test, checked every calibration, compared the image against previous observations of 3-eye divided by Atlas from when it had first been detected 8 months earlier as a small point of light moving against the background stars with a velocity that immediately marked it something extraordinary, something from beyond our sun's gravitational embrace, only the second interstellar object ever confirmed, the second visitor from the vast dark between the stars. The first observations had shown nothing unusual, just a faint dot that might have been a comet, or might have been an asteroid, too distant and too small to resolve any detail, but important simply because of where it had come from. Important because it represented a sample of another star system, a piece of someone else's planetary formation process, a gift from the galaxy. But this new image, this impossible image, showed that 3-eye divided by Atlas was far from ordinary even by interstellar standards. The resolution was extraordinary, sharp enough to see structure in that glowing corona, Patterns that repeated themselves every 6 hours and 43 minutes. Patterns that the imaging team spent an entire night trying to explain through natural processes and kept failing to explain, kept running into walls where the physics didn't quite work, where the energy requirements exceeded what any comet should be capable of producing. One of the younger researchers, a postdoctoral fellow who had only been with the project for 3 months, suggested perhaps they were seeing some kind of crystalline structure in the ice, some lattice that was catching and refracting light in unusual ways, and for a few hours that explanation seemed to hold, seemed to offer a rational way out of the growing sense that they were looking at something that defied categorization. But then the time series analysis came back, showing that the patterns weren't static, that they were evolving, shifting, reconfiguring themselves in ways that no crystal structure could account for, in ways that suggested not dead geology, but something more disturbing, something that made them all uncomfortable, with words like active or responsive or aware, words that belonged to biology and not to chunks of rock and ice falling through the void. When the image was finally released to the astronomical community at large, the response was immediate and intense. Within 6 hours, every major observatory on Earth was trying to point their instruments at 3I divided by Atlas, trying to get their own data, their own spectra, their own confirmation of what Hubble was showing. Radio telescopes swung toward that patch of sky, looking for any emissions that might explain the glow, any signals that might suggest some kind of electrical or magnetic activity. Infrared satellites measured its temperature profile, finding that the object was indeed warmer than it should be, several degrees warmer, radiating heat as if something inside was generating energy through processes that remained mysterious. X-ray observatories found nothing, which was somehow more unsettling than finding something, because it meant that whatever was happening wasn't the result of high-energy processes, wasn't some kind of intense nuclear or particle interaction, but rather something subtle, something happening at lower energies, something almost gentle in the way it produced that living glow. The social media response was predictable and overwhelming. Within a day of the image going public, hashtags about 3I divided by Atlas were trending worldwide, and the usual spectrum of human reaction played out in accelerated digital time. There were the skeptics who insisted it was all a hoax or a misinterpretation, that scientists were seeing patterns where none existed, that the human brain was wired to find faces in clouds and meaning in randomness. There were the enthusiasts who immediately declared that this was proof of extraterrestrial intelligence, that the object was clearly some kind of spacecraft or probe, that humanity was being visited or observed or tested. There were the artists who took the image and transformed it into paintings and digital works and musical compositions, trying to capture the eerie beauty of that pulsing light. There were the prophets who wove it into existing belief systems or created new ones, declaring that this was a sign of coming transformation or destruction or enlightenment. And there were the vast majority who simply looked at the image with a mixture of wonder and unease, who felt in some wordless way that they were witnessing something important, something that marked a boundary between one kind of human understanding and another. The astronomers themselves were divided, not about the reality of what they were seeing, the data was too good, too consistent, too verified, but about what it meant. Some argued forcefully that this was simply exotic chemistry, that interstellar space was full of surprises, that we had only observed a handful of objects from beyond our solar system and therefore had no basis for declaring anything impossible. They pointed out that Earth's oceans were full of organisms that produced bioluminescence, that created light through chemical reactions, and perhaps something similar was happening here. Not life in any sense we would recognize, but complex organic chemistry energized by cosmic rays or by radioactive decay or by some interaction with the interstellar medium that we had never observed before. Others were more cautious, pointing out that the energy requirements for the observed glow were substantial. that maintaining such activity for the weeks and months that 3I divided by Atlas had been under observation would require either an enormous reservoir of chemical energy or some other mechanism entirely, perhaps something involving quantum effects and supercooled materials, or exotic states of matter that only existed in the deep cold between the stars. A small but growing group began to argue, carefully and with extensive hedging, that perhaps the object wasn't entirely natural, that perhaps they were seeing evidence of technology, or at least something shaped by processes more directed than random accretion and gravitational collapse. These voices were immediately controversial, immediately accused of sensationalism or of abandoning scientific rigor, but they persisted, quietly building their case from the data itself. They pointed to the regularity of those pulsing patterns, to the 6-hour 43-minute cycle that never varied by more than a few seconds, to the way the light seemed to concentrate itself in specific regions of the corona, regions that shifted position but maintained their structure, like something that was being controlled or modulated rather than simply radiating randomly. They noted that the object's trajectory, when calculated backwards through the galaxy, suggested it had originated from the direction of the constellation Cygnus, from a region of space dense with young stars and planetary systems, a region where the formation of complex chemistries and perhaps even life would be more probable than in the older, metal-poor regions of the galaxy. The mathematics of its orbit were themselves strange and beautiful, a hyperbolic path that would carry it through our solar system in a long, stretched curve, never to return, a one-time visitor making a brief transit through our little corner of cosmic space before continuing its journey through the galaxy for eons to come. The orbital dynamics team calculated that 3I divided by Atlas had been traveling through interstellar space for somewhere between 40 and 400 million years, depending on assumptions about where exactly it had originated and what gravitational influences it had encountered along the way. 400 million years was a span of time that made the mind stumble, that was longer than mammals had existed on Earth, that reached back to an era when life on our planet was still mostly confined to the oceans, when the continents were arranged in configurations that would be unrecognizable to modern eyes, when nothing that could think, or dream, or wonder yet walked beneath our yellow Sunday. And through all that vast duration, 3I divided by Atlas had been falling through the dark, falling through a void so empty that it would encounter on average only a few atoms of hydrogen per cubic meter, falling through a silence so profound that it made the quiet of Earth's deepest caves seem loud by comparison. What might such a journey do to an object? The philosophers asked, those who thought about these things in broader terms than just data and measurement. If 3I divided by Atlas was indeed something more than simple rock and ice, if there was anything about it that could be called active or aware or responsive, what would that awareness be like after hundreds of millions of years in the absolute cold and dark, with nothing to sense except the faint pressure of starlight and the occasional impact of cosmic dust, with no change, no variation, nothing but the endless fall through a space so vast that even traveling at tens of thousands of kilometers per hour meant covering distances that defied comprehension on human timescales. The science fiction writers had imagined generation ships and frozen colonists and artificial intelligences waiting patiently for arrival at distant destinations. But those stories almost always involved journeys of centuries or perhaps millennia, not the deep time that 3I divided by Atlas had experienced, not the kind of duration that outlasted species and geological epochs and ice ages. If something in or on that object could think, could remember, could anticipate, then it had been thinking and remembering and anticipating through a span that made all of human history look like a brief moment, like a single breath drawn and released. But these were speculations, the scientists reminded everyone, imaginative exercises that might inspire research directions but shouldn't be confused with evidence. What they had was an image and some spectroscopic data and some measurements of brightness and temperature, and while all of that was unusual and intriguing and worthy of intense study, it didn't constitute proof of anything extraordinary, at least not yet. The proper response was to gather more data, to make more observations, to build better models, and test them rigorously against reality. And so the observations continued, night after night, telescope after telescope, as 3I divided by Atlas continued its long fall toward the inner solar system, coming closer to the Sun and to Earth, close enough eventually that larger instruments would be able to resolve even finer details, would be able to see individual features on its surface, would be able to measure the composition of that glowing corona with enough precision to perhaps finally answer the questions that were multiplying faster than the answers. The European Space Agency announced that they were reprogramming one of their deep space missions, a probe that had been scheduled to visit an asteroid in the main belt, redirecting it toward a trajectory that would bring it within 10,000 kilometers of 3I, divided by Atlas in approximately 7 months. The Chinese space program announced something similar, a fast flyby mission that would be launched within 60 days and would reach the object in 4 months, carrying instruments capable of measuring magnetic fields and particle fluxes and surface composition with far greater precision than any Earth-based telescope could achieve. NASA began accelerated planning for their own mission, something more ambitious, something that might actually rendezvous with the object rather than simply flying past, perhaps even landing a small probe on its surface if the conditions allowed. If the object's rotation and that mysterious glow didn't make such an approach too dangerous. The price tags for these missions were substantial, hundreds of millions of dollars or euros or yuan, but the funding materialized with unusual speed because everyone understood that this was a unique opportunity, that 3I divided by Atlas would only be within reach for a few more months before it swung around the Sun and headed back out toward the interstellar medium, unreachable again for lifetimes or perhaps forever. The public imagination was fully engaged now in a way that astronomical discoveries rarely achieved. The image of 3I divided by Atlas appeared on magazine covers and news programs, was discussed in classrooms and coffee shops, became a reference point in culture, in art, in the collective conversation that humanity was having with itself about its place in the universe. There was something about that glowing corona, about those rhythmic pulses of light that captured attention in a visceral way, that bypassed the usual filters of cynicism or indifference and spoke directly to some ancient part of the human psyche that responded to patterns and mysteries, to things that moved in the night sky with apparent purpose, to signs and wonders that suggested the world was stranger and more full of possibility than everyday experience indicated. Children drew pictures of it in school, depicting 3I divided by Atlas as a friendly visitor or sometimes as a threat, projecting their hopes and fears onto that distant point of light. Teenagers made it into memes, finding humor in the cosmic strangeness, using the image as a template for jokes about alienation and wonder, and the absurdity of caring about anything when confronted with such vast scales of space and time. Adults discussed it at dinner parties, argued about what it might mean, what humanity should do if it turned out to be something more than a comet, whether we should try to communicate with it or study it from a distance, or simply appreciate it as a natural phenomenon requiring no response beyond observation and understanding. The astrobiologists were particularly excited, though they tried to contain their enthusiasm within the bounds of professional skepticism. For decades they had been arguing that life should be common in the universe, that the chemistry that produced life on Earth was based on abundant elements and should occur anywhere that conditions were suitable, that the galaxy should be full of organisms ranging from simple bacteria to complex multicellular creatures to perhaps even beings with intelligence and technology. But the evidence for this hopeful proposition had been frustratingly indirect, limited to the detection of organic molecules in meteorites and comets, to the discovery of potentially habitable planets orbiting distant stars, to laboratory experiments showing that the building blocks of life could form spontaneously under a wide range of conditions. There had been tantalizing hints, disputed biosignatures in Martian meteorites, unexplained atmospheric chemistry on Venus, curious patterns in the dimming of certain stars that some argued might be artificial megastructures, but nothing definitive. Nothing that could settle the question of whether Earth's life was unique or merely one example of a common cosmic phenomenon. 3I divided by Atlas, whatever it turned out to be, represented the most direct evidence yet that complex chemistry and perhaps even something like life could exist beyond our solar system, could survive in the harshest environment imaginable, could perhaps even thrive in ways that made our earthbound assumptions about habitability and survival seem provincial and limited. The spectroscopic data grew richer as more observatories contributed their measurements, building up a detailed picture of what molecules and atoms were present in that glowing corona. The results were simultaneously encouraging and baffling to the astrobiologists. On one hand, they found many of the molecules they expected from a comet: water, carbon monoxide, carbon dioxide, methane, ammonia, all the simple volatile compounds that should be present in any collection of ice and rock assembled in the cold outer regions of a stellar system. But mixed in with these familiar substances were others that were harder to explain, complex organic molecules that on Earth were associated with biological processes, molecules like formaldehyde and hydrogen cyanide, and even traces of amino acids, the building blocks of proteins. Now, the scientists were careful to point out that the presence of amino acids didn't automatically mean life, that these molecules could form through purely abiotic processes, that in fact they had been detected in other comets and in interstellar clouds and even in laboratory simulations of early Earth conditions. But the concentrations were high, higher than expected, and the specific mixture of amino acids was unusual, skewed towards certain types in a way that suggested, though didn't prove, some kind of selection process, some reason why certain molecules were more abundant than others beyond simple chemistry. More intriguing still were hints of even more complex molecules, long-chain hydrocarbons and aromatic compounds, and things that the spectroscopists couldn't quite identify, signatures in the infrared spectrum that didn't match anything in their databases, that suggested the presence of molecules with structures so elaborate that their spontaneous formation through random chemistry seemed unlikely, though not impossible. The biologist noted that these were the kinds of molecules that on Earth required enzymes to construct, that required the machinery of cells and metabolism and evolution, but they also acknowledged that alien chemistry might work differently, that processes that required biology on Earth might be spontaneous under different conditions, under different temperatures and pressures and radiation environments. The debate continued, careful and rigorous, with no one willing to make definitive claims, but everyone recognizing that the chemical evidence was at minimum very interesting and at maximum potentially revolutionary. The images kept coming as Hubble and other telescopes maintained their watch on 3I divided by Atlas, capturing its slow tumble through space, documenting the evolution of that pulsing glow. And the patterns became clearer over time, more distinct, more obviously structured. The imaging teams spent weeks processing the data, applying every enhancement technique they knew, building up three-dimensional models from multiple observations, trying to understand the geometry of what they were seeing. What emerged from this analysis was startling. The light wasn't distributed uniformly around the object, but was concentrated in specific regions that formed geometric arrangements. Not perfect geometry, but close enough to make the analysts uncomfortable, close enough to suggest organization rather than chaos. There were 6 primary bright regions arranged roughly in a hexagonal pattern, each one connected to its neighbors by fainter tendrils of light that formed a network, a web, A structure that looked disturbingly like a circuit or a nervous system or some kind of distributed network designed to carry energy or information or both from one part of the object to another. The skeptics immediately argued that this apparent structure was an artifact of the human tendency to find patterns, that if you looked at any sufficiently complex natural phenomenon long enough, you would start to see organization where none existed, that clouds and mountain ranges and coastlines all seemed to show patterns if you squinted at them the right way, but that didn't mean they were designed or intentional. And this argument had merit, had to be taken seriously, because pattern recognition was indeed a powerful force in human perception, was indeed responsible for seeing faces in toast and hearing messages in random noise and finding meaning in the arrangements of stars that were separated by hundreds of light years and had no physical connection to each other. But the imaging scientists had tools to test for this kind of cognitive bias, statistical methods that could quantify how likely a given pattern was to arise from random processes. And when they applied these tests to the structure around 3I divided by Atlas, the results were troubling. The probability that the hexagonal arrangement of bright regions was accidental was low. Not impossibly low, but low enough to warrant serious consideration of alternatives, low enough that dismissing it as pattern-seeking felt intellectually dishonest. One of the more creative researchers proposed a natural explanation that gained some traction. Perhaps 3I divided by Atlas had formed in an unusual way. Perhaps it was the remnant of a collision between two smaller objects that had happened millions of years ago, and the hexagonal pattern was a residual stress pattern in the material, fractures or crystal boundaries that were now sublimating preferentially, creating bright spots where outgassing was more intense. The impact modelers ran simulations, tried to reproduce the observed structure through plausible collision scenarios, and they found that yes, under certain very specific conditions, you could get something that looked vaguely similar, but it required fine-tuning the parameters in ways that seemed contrived, that seemed to be working backward from the answer rather than forward from first principles. And even if the collision hypothesis was correct, it didn't explain the temporal patterns, the 6-hour 43-minute cycle, the way the bright regions seemed to pulse in synchronization as if responding to some common signal or sharing some common energy source. Collisions were messy, random, chaotic events that destroyed structure rather than creating it. And while the universe was full of surprises and sometimes order emerged from chaos in unexpected ways, the more the scientists looked at the data, the less convinced they became that purely geological or chemical processes could account for everything they were seeing. The timeline was approaching a critical point. In approximately 11 weeks, 3I divided by Atlas would reach perihelion, its closest approach to the Sun, coming within about 0.9 astronomical units, just inside Earth's orbit. Close enough that solar heating would be intense. Close enough that any volatiles on its surface would be violently sublimating, creating a tail that might stretch for millions of kilometers and would certainly make the object far more active than it currently was. Comets at perihelion were spectacular, often became visible to the naked eye from Earth, generated enormous comas and tails as their surfaces boiled away under the sun's radiation. If 3I divided by Atlas behaved like a normal comet during this passage, it would put on quite a show, would likely become one of the brightest objects in the night sky for several weeks, would be studied intensively by every astronomer on the planet. But there was growing concern that it might not behave normally, that whatever was causing that strange glow might react to increased solar heating in unpredictable ways, might intensify or might shut down or might do something entirely unexpected that would either answer all the questions or create new ones. The mission planners were watching the timeline carefully, calculating and recalculating trajectories for the proposed spacecraft missions. The European probe was already being prepared, was scheduled to launch in 32 days, would accelerate quickly using a combination of conventional rockets and a solar sail, would reach 3I divided by Atlas about 2 weeks after perihelion, when the object was heading back out toward the outer solar system. The Chinese mission was more aggressive, aiming for a pre-perihelion encounter, trying to study the object in its current state before the sun's influence became dominant. NASA's proposed rendezvous mission was still in the planning stages, probably wouldn't launch for 6 months or more, but would be capable of matching velocity with 3I divided by Atlas, and potentially staying with it for weeks or months, sending back continuous data, maybe even deploying a lander if conditions were right and funding was approved and political support held. The cost estimates kept climbing as the engineering challenges became clearer, but there was momentum now. Public interest and scientific enthusiasm combining to push the project forward despite the usual bureaucratic obstacles and budget constraints. Meanwhile, the professional and amateur astronomical community maintained constant vigilance, documenting every detail of 3I divided by Atlas's appearance and behavior. Time series photometry showed that the overall brightness was slowly increasing, not dramatically, but measurably, suggesting that outgassing was indeed beginning as solar heating intensified, though the object was still too far from the sun for this to be expected based on normal comet behavior. The spectrum was evolving as well, with emission lines becoming stronger and new features appearing. New molecular signatures that indicated an increasingly complex chemistry as more material was released from the surface and interacted with sunlight and with the particles of the solar wind. Radio observations detected weak but definite emissions at certain frequencies, not the kind of coherent signals that would indicate intelligence or technology, but rather the natural electromagnetic noise that came from ionized gases and dust, from electric currents flowing through the expanding corona, from the interaction of charged particles with magnetic fields, if any existed around the object. The question of whether 3I divided by Atlas had a magnetic field was particularly interesting to the planetary scientists. Most comets didn't have intrinsic magnetic fields because they were too small and too cold to maintain the kind of liquid metal cores that generated planetary magnetism, but there were indirect ways that magnetic fields could arise, through the interaction of the solar wind with outgassing material or through the presence of magnetized minerals in the rock and ice. If 3I divided by Atlas had a magnetic field, even a weak one, it would tell them something about its internal structure, about whether it was a solid monolithic object or a loose collection of fragments held together by weak gravity, about whether it contained metals and where those metals were located. The early magnetic measurements were ambiguous, showing some evidence for fields but not strong enough or consistent enough to be certain. Definitely something that the spacecraft missions would need to investigate more carefully with closer, more sensitive instruments. In the weeks that followed the image release, the scientific papers began to appear, first as preprints on the ArXiv, then in peer-reviewed journals, each one presenting a different analysis or interpretation of the growing dataset. Some papers focused on the chemistry, using the spectroscopic data to build models of what the interior composition might be, what processes might be occurring to generate the observed molecules and emission lines. Other papers addressed the dynamics, analyzing the rotation rate and the tumbling motion, trying to understand the object's shape and mass distribution from the way light reflected off different parts of the surface as it spun. Still, others tackled the thermodynamics, calculating energy budgets and heat flows, trying to determine whether the observed temperature and brightness could be explained by solar heating alone, or whether some additional energy source was required. Some internal heat or chemical reactions or radioactive decay, or something else entirely. The consensus that emerged from these papers was cautious but clear. 3I divided by Atlas was definitely unusual, definitely worthy of the intense scrutiny it was receiving, definitely something that challenged existing models and would require new thinking to fully understand. The historical perspective helped put things in context. 3I divided by Atlas was only the second confirmed interstellar object, but it was being studied with far greater intensity and sophistication than the first one had been. That first visitor, designated 1I divided by Oumuamua, had been discovered in October 2017 as it was already heading back out of the solar system, giving astronomers only a few weeks to observe it before it became too faint and too distant to detect. The data from Oumuamua had been limited but tantalizing, showing an object that was highly elongated, that tumbled end over end, that exhibited a slight acceleration that couldn't be entirely explained by ordinary outgassing and had led to considerable debate about whether it might be something other than a comet or asteroid, whether it might even be artificial, a probe or spacecraft from another civilization. Though most scientists eventually concluded it was probably a natural object with unusual properties that arose from its particular formation history and interstellar journey. The lack of detailed data from Oumuamua had been frustrating, had left many questions unanswered, had taught the astronomical community that they needed to be ready to respond quickly when the next interstellar visitor arrived, needed to have plans in place and resources allocated so they could maximize the scientific return from what would inevitably be a brief opportunity. And now here was 3I divided by Atlas, arriving on a trajectory that gave them months instead of weeks, appearing while it was still far enough from the sun to be in a relatively pristine state, displaying characteristics that were far more dramatic and mysterious than anything Oumuamua had shown. This was the opportunity the community had been hoping for, the chance to really study an interstellar object in detail, to learn what other stellar systems were like by examining this sample that had traveled across the galaxy to reach them. The scientists were determined not to waste this chance, were mobilizing resources on a scale rarely seen in planetary astronomy, were setting aside other projects and research programs to focus on this one target, because they knew that opportunities like this came perhaps once in a lifetime if you were very lucky, and that the data they gathered over the coming months might reshape understanding of planetary formation and comet composition, and perhaps even the prevalence of life in the universe. The philosophical implications were being discussed as well, not just among philosophers but among the scientists themselves and in the broader culture. There was something humbling about 3I divided by Atlas, about the recognition that it had existed for hundreds of millions of years before humanity appeared, had been traveling through the galaxy while Earth's continents were still moving toward configurations that would eventually support human civilization, while life on this planet was undergoing the endless experiments of evolution that would eventually produce consciousness and language and telescopes capable of detecting a small moving point of light against the stellar background. And there was something deeply moving about the fact that this ancient traveler happened to pass through our solar system at a moment when we were capable of noticing it, when we had developed the technology and the curiosity to study it, when we were at a stage in our development where such a discovery could mean something beyond simply noting that a strange object had appeared in the sky. The timing felt almost providential, though of course it wasn't, was simply the result of random orbital mechanics and the fact that the galaxy was full of debris and eventually some of it had to pass close enough to be detected. But even random events could carry meaning, could serve as focal points for reflection and wonder, could remind people that existence was stranger and more full of mystery than daily life usually acknowledged. The image of 3I divided by Atlas, with its pulsing corona and geometric patterns, had become a symbol of that strangeness, a reminder that the universe was not fully mapped or fully understood, that there were still discoveries to be made and questions to be asked, that the cosmos was not a dead clockwork mechanism, but a dynamic, evolving, endlessly creative process that generated novelty and complexity and sometimes things that looked almost like purpose, even when they were probably just the result of blind physical law operating across vast scales of space and time. Whether 3I divided by Atlas was a comet or something more, whether its glow was chemistry or biology or technology or some combination or something entirely different, it represented the possibility of surprise, the possibility that reality was larger and stranger than current models suggested, and that possibility alone was valuable, was worth celebrating and exploring and taking seriously. The religious communities had their own responses to the discovery. responses that varied widely depending on theological framework and cultural context. Some saw 3I divided by Atlas as a sign from God or the gods, a messenger carrying meaning that would be revealed in time, a reminder of divine power and cosmic order. Others viewed it more naturalistically, as simply another part of creation to be appreciated and studied, no more or less significant than any other part of the natural world, interesting but not necessarily laden with special meaning. A few worried that it represented some kind of judgment or warning, that the appearance of something so unusual and potentially threatening was a sign that humanity needed to change its ways or face consequences, though what those consequences might be was left vague and subject to considerable interpretation. And many religious people simply watched with the same mixture of curiosity and wonder as everyone else, not feeling compelled to immediately integrate the discovery into their existing belief systems, but rather allowing themselves to sit with the uncertainty and mystery, to appreciate the fact that the universe was capable of surprising them, that their understanding of reality was incomplete and would probably remain so regardless of what future observations revealed. The artists continued to engage with 3I divided by Atlas in increasingly creative ways. Musicians composed pieces inspired by that 6-hour 43-minute cycle, creating rhythms and harmonic structures that echoed the pulsing pattern, translating light into sound and inviting listeners to experience the cosmic rhythm through a different sensory modality. Visual artists painted and photographed and sculpted their interpretations, some trying for scientific accuracy and others using the object as a starting point for more abstract explorations of form and color and texture. Writers crafted stories about what 3I divided by Atlas might be, where it might have come from, what might happen when it reached perihelion, what the spacecraft missions might discover. Using the real scientific mystery as a framework for imaginative speculation that ranged from hard science fiction grounded in current knowledge to fantasy that abandoned realism entirely in favor of metaphor and symbolism. The cultural production around 3I divided by Atlas was remarkable in its diversity and intensity, reflecting the fact that the discovery had touched something deep in the human psyche, had awakened that ancient sense of wonder at the night sky that had been diminished but never extinguished by artificial lights and digital distractions. In the universities and research institutions, graduate students were frantically writing proposals and applications, hoping to make 3I divided by Atlas the subject of their thesis research, recognizing that this was the kind of once-in-a-career event that could launch a successful academic trajectory if they could just get access to the data, get time on the telescopes, and get funding to attend conferences and collaborate with the major research groups. The competition was intense but collegial, with most researchers recognizing that there was enough interesting science to go around, that this wasn't a zero-sum game where one person's success meant another's failure, but rather a collaborative enterprise where different perspectives and approaches would all contribute to building a fuller understanding of what they were seeing. The senior scientists, those who had been in the field for decades and had seen many discoveries come and go, understood that 3I divided by Atlas was special, was something that would be remembered and discussed for generations, and they felt privileged to be working during this particular moment, to have the skills and resources and knowledge to contribute to unraveling the mystery. The media coverage continued at a high level, with major news outlets running regular updates on the latest observations and analyses, interviewing astronomers and astrobiologists and planetary scientists, trying to convey the excitement and significance of the discovery to a general audience that was interested, but often lacking the technical background to fully appreciate the nuances. Some of the coverage was excellent, featuring journalists who had taken the time to really understand the science and could explain it clearly without dumbing it down or sensationalizing it. Other coverage was less good, falling into the trap of overhyping the discovery or misrepresenting what the scientists were actually saying or drawing conclusions that weren't supported by the evidence. The scientists themselves tried to engage responsibly with the media, tried to communicate their findings accurately while also conveying the genuine excitement and uncertainty that characterized the research process, tried to push back against exaggerations while not being so conservative that they downplayed the legitimate significance of what was being observed. The countdown to perihelion continued, with each passing day bringing 3I divided by Atlas closer to the Sun and increasing the anticipation about what would happen when it reached that critical point. The orbital mechanics were well understood, the trajectory calculated with high precision, the date and time of closest approach known to within a few seconds. What wasn't known was how the object would respond to the intense solar heating, whether the strange glow would intensify or fade, whether new phenomena would emerge or existing patterns would break down, whether the increase in activity would reveal something fundamental about the object's nature or simply create more complicated data that would take years to fully interpret. The scientists had developed multiple scenarios based on different assumptions about composition and structure and energy sources, and they had plans for responding to each scenario, observation protocols, and analysis pipelines ready to be deployed depending on what actually happened. But everyone understood that nature might not cooperate with any of their scenarios, might do something entirely unexpected that would require improvisation and creative thinking and rapid adaptation of strategies and techniques. The European Space Agency's probe launched on schedule. A perfect launch on a clear morning, the rocket climbing smoothly through the atmosphere and releasing the spacecraft on a trajectory that would carry it toward its rendezvous with 3I divided by Atlas in just over 3 months. The probe was relatively small, about the size of a washing machine, carrying a compact suite of instruments designed to make measurements that were impossible from Earth, a magnetometer to map any magnetic fields, a dust analyzer to examine particles in the corona, a mass spectrometer to precisely determine the composition of outgassing materials, cameras capable of resolving features as small as a few meters across on the object's surface. The mission team was experienced, had successfully managed several previous deep space missions, but they were also acutely aware that this one was different, that the target was unusual and potentially unpredictable, that they would need to be flexible and responsive to whatever conditions they encountered. The spacecraft was designed with considerable autonomy, capable of making certain decisions on its own if communications with Earth were delayed or if conditions changed more rapidly than ground controllers could respond. Though there were also strict safety protocols to ensure it wouldn't do anything that might damage itself or contaminate the target or interfere with other observations. The Chinese mission followed 6 weeks later, launching on a larger rocket that gave it more velocity and allowed for a different trajectory, one that would bring it close to 3I divided by Atlas about a week before perihelion, giving them a chance to see the object in its most active state before the solar heating reached its peak. The Chinese space program had been increasingly ambitious in recent years, had successfully landed rovers on the Moon and Mars, had begun construction of their own space station, and saw this mission as another opportunity to demonstrate their capabilities in deep space exploration. Their spacecraft was somewhat larger than the European probe, carried a different mix of instruments, including a small sub-probe that could potentially be deployed to make contact with the surface if the primary spacecraft determined that such an approach was safe. The international coordination was good, with the various space agencies sharing data and coordinating observation plans to ensure that their missions complemented rather than duplicated each other's efforts, recognizing that they were all part of a common human enterprise to understand this mysterious visitor. As perihelion approached, the ground-based observations intensified. Telescopes around the world were scheduled to observe 3I divided by Atlas continuously for the 2-week period centered on closest approach, creating an unprecedented dataset that would capture every detail of its behavior as solar heating reached maximum. The amateur astronomers were mobilized as well, hundreds of backyard telescope operators ready to contribute their observations, to provide continuous coverage that no single professional facility could match, to watch for transient events or unexpected changes that might be missed by the scheduled robotic surveys. The sense of collective participation was strong, the feeling that this was a shared human moment, that people across all continents and cultures were looking up at the same object and wondering about the same questions, united by curiosity and the desire to understand. And then, 3 days before perihelion, something changed. The regular pulsing pattern that had been so stable for months, that 6-hour 43-minute cycle that had become familiar from countless observations, suddenly shifted. The period shortened by almost an hour, dropping to 5 hours and 51 minutes, and the amplitude of the brightness variations increased significantly, nearly doubling. The first reports came from an automated monitoring program that immediately flagged the anomaly and sent alerts to the astronomers on duty. Within hours, every available telescope was confirming the change, watching as 3I divided by Atlas seemed to accelerate its internal rhythm, as if responding to the increasing proximity of the Sun, as if preparing for something. The spectroscopic signatures changed as well, with certain emission lines becoming much stronger, while others faded, suggesting that the chemistry in the corona was undergoing rapid evolution, that new processes were activating or old ones were intensifying, that the object was transforming in real time in response to external stimuli. The scientific community reacted with a mixture of excitement and concern. This was exactly the kind of dynamic behavior they had hoped to observe, the kind of change that could provide crucial insights into what 3I divided by Atlas actually was and how it worked. But it was also unexpected enough to raise questions about whether their models and predictions were valid, whether the spacecraft missions would encounter conditions very different from what they had planned for, whether there might be risks that hadn't been adequately considered. Emergency meetings were convened, with mission planners and instrument specialists and theorists all trying to rapidly update their understanding and adjust their plans accordingly. The general consensus was to proceed with the missions as planned, but with increased caution, with more conservative safety margins, with readiness to abort or modify maneuvers if conditions turned out to be hazardous. The change in behavior triggered a new wave of speculation about what 3I divided by Atlas might be. Those who had been arguing for a technological interpretation saw the shift as evidence of responsiveness, of a system that could detect changes in its environment and adjust its behavior accordingly, something that seemed more consistent with designed mechanisms than with natural processes. The natural explanation advocates countered that this was simply how complex chemical systems worked, that they often had thresholds and feedback loops that produced sudden transitions when conditions changed beyond certain critical points. That phase changes and chemical reactions could easily generate the kind of behavior being observed without requiring any kind of intelligence or design. The debate was vigorous but remained professional, with both sides acknowledging that the data was still limited, that they were all operating with significant uncertainty, that definitive conclusions would have to wait for more evidence. Perihelion arrived on a Tuesday at exactly 14 hours, 37 minutes, and 42 seconds Universal Time. At that moment, 3I divided by Atlas was approximately 135 million kilometers from the Sun, well inside Earth's orbit, experiencing solar radiation intensity comparable to what Earth receives on a summer day, though of course the object had no atmosphere to moderate that radiation, no magnetic field to deflect the solar wind, nothing but its own material properties to protect it from the Sun's influence. The observing campaign was in full swing, with dozens of telescopes and instruments all focused on that single point in space, recording data across every available wavelength from gamma rays to radio waves, capturing images and spectra and polarimetry and everything else that might provide clues about what was happening. And what happened was beautiful and terrifying, and utterly unlike what anyone had predicted. The pulsing pattern didn't just intensify, it transformed. The 6 bright regions that had formed that rough hexagonal arrangement began to move, began to rotate around the central nucleus in a coordinated dance that suggested connection and communication and coordination. Tendrils of light extended from each bright region toward the center, met and merged into a brilliant core that blazed with intensity far exceeding what solar heating alone could produce. creating a star-like point that was visible in amateur telescopes from Earth, despite the object being relatively small and distant. The spectroscopic data showed that this central brightness was coming from ionized gas heated to tens of thousands of degrees, temperatures that implied enormous energy densities that suggested something was releasing or concentrating or focusing energy in ways that defied easy explanation. The transformation lasted for approximately 43 minutes, that same number that had appeared in the original pulsing period. And during those 43 minutes, 3I divided by Atlas was the most intensely studied object in the solar system, aside from the sun itself, was being observed with greater attention and more sophisticated instruments than any comet or asteroid in history. The data flowed into archives and hard drives and computer memories around the world, petabytes of information that would take months or years to fully analyze. But even the preliminary real-time assessment made it clear that something extraordinary was occurring, something that challenged fundamental assumptions about what was possible for a small icy body in space. And then, as suddenly as it had begun, the display ended. The bright regions slowed their rotation, the central light dimmed, the tendrils withdrew, and 3I divided by Atlas returned to something resembling its previous state, though not exactly the same. Never exactly the same again. The pulsing pattern resumed, but with yet another new period, now 8 hours and 17 minutes, and the brightness was somewhat lower than before, as if the object had expended energy during that perihelion display and was now in some kind of recovery or recharge phase. The spectroscopic signatures showed signs of chemical exhaustion, with certain molecules that had been abundant now greatly reduced, while other species that had been absent or rare were now prominent, suggesting that the perihelion event had indeed involved significant outgassing and chemical transformation, though the specifics would require detailed analysis to understand. The immediate aftermath of perihelion was chaos, organized chaos, but chaos nonetheless, as scientists scrambled to process what they had just witnessed, to update models and theories, and to figure out what it all meant. The imagery was stunning. Some of the most beautiful astronomical photographs ever captured, showing 3I divided by Atlas surrounded by that complex evolving corona of light, glowing with an intensity and structure that made it look less like a comet and more like some kind of cosmic organism going through a life cycle event, blooming or birthing or dying or being reborn. The images went viral immediately, were shared millions of times across social media, were featured on the front pages of newspapers and websites around the world, because even people with no particular interest in astronomy could see that this was something special, something rare, something that transcended the usual categories and demanded attention. The first spacecraft encounter was now only 5 days away, with the Chinese probe scheduled to make its closest approach to 3I divided by Atlas on Sunday morning. The mission team was working around the clock to update their plans based on the perihelion observations, adjusting the flyby trajectory slightly to account for the fact that the object's activity was higher than expected, that there was more dust and gas around it than their original models had predicted, that the environment might be more hazardous to the spacecraft's delicate instruments and electronics. But they were also excited beyond measure, because they knew their probe would get close enough to see details that no Earth-based telescope could resolve, would fly through that glowing corona and directly sample its composition, would carry back data that would finally, hopefully, decisively answer at least some of the questions that had been multiplying since that first strange image had arrived from Hubble months earlier. The days before the encounter were filled with preparation and anticipation. The spacecraft was healthy, all systems functioning nominally, communications strong and clear. The instruments were powered up and calibrated, ready to collect data during the brief but intense flyby that would last only a few hours from first detection to final departure. The ground stations were ready, their massive antenna dishes pointed toward the expected location of the spacecraft, ready to receive the precious data that would be transmitted back in real time as the encounter progressed. The mission control room was crowded with engineers and scientists and administrators and media representatives, everyone watching the displays and waiting for the signal that would indicate the probe had begun its final approach. The encounter began exactly on schedule, with the spacecraft's navigation cameras first detecting 3I divided by Atlas as a faint point of light against the background stars, gradually growing brighter as the distance decreased. The probe was approaching from an angle that would take it past the object at a distance of approximately 8,000 kilometers, close enough to get excellent imagery and measurements, but far enough to avoid the densest regions of dust and gas that might damage sensitive components. The first detailed images began arriving 20 minutes before closest approach, and they were revelatory, showing the surface of 3I divided by Atlas in unprecedented detail, showing features and structures that immediately generated new questions even as they answered old ones. The surface was not smooth and uniform as a typical comet nucleus would be, not the dirty snowball that the simplest models predicted. Instead, it showed distinct regions with different characteristics, areas that appeared darker and rougher, alternating with areas that were lighter and smoother, boundaries between these regions that looked almost engineered in their sharpness and regularity. There were no obvious craters, no signs of the impact history that should mark any object that had been traveling through space for millions of years, encountering dust and debris and small rocks that would chip and scar and crater the surface. The absence of craters was itself telling, suggesting either that the object was very young, which seemed impossible given its interstellar origin, or that its surface was somehow self-healing, was being renewed or reformed through processes that erased impact damage over time. The bright regions that generated the pulsing glow were visible as distinct features on the surface, appearing as roughly circular areas several tens of meters across, each one surrounded by a network of fine structures that looked like channels or veins, linear features that connected the bright spots to each other and to other parts of the surface in patterns that the imaging team immediately recognized as non-random. The statistical analysis would take hours to complete, but even visually it was obvious that these weren't natural geological features like the ones you'd see on Earth's surface or on the Moon or Mars, weren't the result of erosion or tectonics or volcanism or any familiar planetary process. They looked purposeful, looked constructed, looked like something that had been laid out according to a plan. The dust analyzer was sampling particles from the corona as the spacecraft flew through, measuring their size distribution and composition and velocity, building up a profile of what the material around 3I divided by Atlas consisted of. The preliminary results showed a mixture of ice crystals and organic grains. The ice mostly water, but also carbon monoxide and methane and ammonia. The organics ranging from simple hydrocarbons to much more complex molecules that the instrument could detect but not fully identify. The size distribution was unusual, showing a preponderance of very small particles, micron-sized grains that would be easily blown away by sunlight pressure, and a population of much larger particles, millimeter-sized chunks that were more typical of cometary debris. But the middle sizes, the particles that should form the bulk of a normal comet's dust output, were largely absent, creating a bimodal distribution that suggested either unusual formation conditions or some process that was selectively removing or destroying particles in that size range. The magnetometer showed that 3I divided by Atlas did indeed have a magnetic field, a weak one but definitely present and definitely anomalous for an object of its size and presumed composition. The field strength varied across the surface, being strongest near the bright regions and weakest in the darker areas between them, suggesting that whatever was generating the field was associated with the same processes that produced the visible glow. The field geometry was complex, not a simple dipole like Earth's magnetic field, or even the more complicated multipole structures seen around some asteroids, but rather a distributed pattern with multiple sources, as if each bright region was generating its own field, and these fields were interacting and interfering to create the overall structure. The fact that the fields from different regions seemed to be synchronized, all pulsing together in that 8-hour 17-minute cycle, suggested some kind of coupling mechanism. In some way, that energy or information was being shared across the object's surface, despite there being no obvious physical connections beyond those vein-like channels. The mass spectrometer was working continuously, analyzing the composition of the gas in the corona with high precision, detecting molecules and determining their abundances, and measuring their velocities and temperatures. The results were astonishing in their complexity, showing hundreds of different species, far more chemical diversity than any previously studied comet, a veritable alphabet of carbon chemistry mixed with nitrogen and oxygen and sulfur and phosphorus and trace amounts of metals and other elements. Some of the detected molecules were familiar from previous comet studies, but others were completely unexpected, were molecules that on Earth were associated exclusively with biological processes, metabolic byproducts, and signaling compounds and structural components of cells. The mass spectrometer team was being extremely careful not to overinterpret this data, not to jump to conclusions about biology when the chemistry might have alternative explanations, but privately they were all thinking about the implications. Were all wondering whether they might be detecting the chemical signatures of life, whether 3I divided by Atlas might be not just a comet but something more, something alive, or at least something that had once been alive, preserved in the frozen deep of interstellar space for eons. The closest approach came and went in a blur of activity, with all instruments collecting data at maximum rate, with every sensor and camera and spectrometer working at full capacity, grabbing as much information as possible during the brief window when the spacecraft was within optimal range. And then the probe was past, was moving away, was looking back at 3I divided by Atlas from the other side, getting a different perspective, seeing the object illuminated from a different angle, capturing images that showed new features and details that hadn't been visible during the approach. The data continued to stream back to Earth, where the mission control room erupted in cheers and applause, celebrating a successful encounter, celebrating the fact that everything had worked as planned, that the probe had survived its passage through the dust and emerged intact and functional on the other side. But the real work was just beginning. The data that had been collected during those few hours of close proximity amounted to terabytes of information, images and spectra, and particle counts and magnetic field measurements and everything else. A treasure trove that would keep scientists busy for years, that would spawn hundreds of papers and probably revolutionize understanding of cometary science and potentially of much more than that. The initial quick-look analysis that happened in the hours and days after the encounter provided just a glimpse of what the data contained, enough to confirm that 3I divided by Atlas was even stranger and more interesting than anyone had imagined. Enough to make it clear that this was indeed an exceptional object that didn't fit neatly into existing categories. The European probe's encounter came 2 weeks later, by which point 3I divided by Atlas was heading back out toward the outer solar system, having swung around the sun and begun its long journey back toward interstellar space. The European mission had the advantage of the Chinese data, could incorporate those findings into their own observation plan, could focus their instruments on particular features that had been identified as especially interesting. Their trajectory was different, came from a different angle, provided a complementary view that filled in details that the Chinese probe had missed. And they had their own suite of instruments with different capabilities and sensitivities, could make measurements that the Chinese probe couldn't, could provide independent verification of some findings and new discoveries of their own. The European encounter confirmed much of what the Chinese mission had found: the structured surface, the complex chemistry, the magnetic fields, the non-random patterns, but also added new pieces to the puzzle. Their higher resolution cameras revealed even finer details in those channel-like structures connecting the bright regions, showed that the channels had internal structure themselves, showed what looked like smaller branches and sub-branches, a hierarchical network that looked disturbingly like a circulatory system or a neural network, or the branching patterns that arise in certain kinds of crystalline growth. Their infrared instruments mapped the temperature distribution across the surface with high precision, found that the bright regions were indeed warmer than their surroundings, several degrees warmer, radiating heat that had to come from internal sources since solar heating alone couldn't account for the observed temperatures. Their radar experiment, which bounced signals off the object and analysed the returns, provided information about the internal structure, suggested that the interior was not homogeneous, but rather had distinct layers or regions with different densities and electrical properties, structure that implied either a complex formation history or perhaps some kind of internal organization. By the time the European mission data was fully downlinked and archived, the astronomical community had reached a tentative consensus, though not without considerable debate and disagreement. The consensus was that 3I divided by Atlas was unlike any comet or asteroid that had ever been studied, that its properties suggested something more complex than simple geology and chemistry, that while a purely natural explanation couldn't be ruled out, it was becoming increasingly difficult to construct such an explanation that accounted for all the observations without invoking processes or conditions that were themselves highly unusual and poorly understood. A minority opinion, held by perhaps 20 or 30 scientists willing to state it publicly, was that the evidence pointed towards something biological or technological, that the patterns and structures and behaviors were more consistent with organization and purpose than with random natural processes. This view was controversial, was criticized by many as premature and speculative, but it was also being taken more seriously than similar claims would have been before the spacecraft encounters, because the data was simply too good and too strange to dismiss easily. The possibility that 3I divided by Atlas might be biological was both exciting and terrifying to contemplate. If there was life on or in that object, if some kind of organisms had survived the hundreds of millions of years' journey through interstellar space, then it would represent the first confirmed detection of extraterrestrial life, would answer definitively one of humanity's oldest and most profound questions, would fundamentally change how we thought about our place in the universe, but it would also raise enormous practical and ethical questions. Was this life still active, or was it dormant or preserved? If it was active, what were its requirements and capabilities? Could it survive on Earth if contamination occurred? Did humanity have any responsibility to protect it or study it or communicate with it if such communication was possible? The planetary protection protocols that govern spacecraft missions were designed primarily to protect Earth from potential back contamination and to protect pristine environments on other worlds from contamination by Earth organisms. But they had been developed with solar system missions in mind, with Mars and Europa and Enceladus, not with visitors from other star systems carrying chemistries that might be radically different from anything Earth's biosphere had ever encountered. The technological hypothesis was even more contentious. If 3I divided by Atlas was some kind of artifact, some kind of probe or vessel or machine built by an intelligent civilization, then its presence in our solar system was almost certainly not coincidence, was either incredibly lucky or suggested that such objects were common enough that we should have been detecting them regularly, which raised uncomfortable questions about why we hadn't. The possibility of deliberate targeting, of 3I divided by Atlas, having been sent specifically to our solar system by beings who knew or suspected that life and intelligence existed here, was exciting and troubling in equal measure. What would such beings want? What should humanity's response be? The SETI community had spent decades thinking about protocols for making contact with extraterrestrial intelligence, about message construction and information theory, and the potential risks of revealing our presence to unknown civilizations, but those discussions had always assumed that contact would come through radio signals or optical transmissions, not through physical objects arriving in our cosmic backyard. NASA's proposed rendezvous mission gained political and financial support in the wake of the Chinese and European encounters, was fast-tracked through the approval process, and given a launch date just 4 months away. The mission design was ambitious, calling for a spacecraft that would not just fly past 3I divided by Atlas, but would match its velocity and orbit, would stay with the object for an extended period, weeks or months, continuously monitoring and studying and perhaps even interacting with it in controlled ways. The mission plan included provisions for deploying a small lander that could touch down on the surface and make direct measurements, could drill samples if the material properties allowed, could potentially even deploy smaller sub-probes that could explore those channel-like structures, could try to determine whether they were hollow or solid, were active or dormant, were natural formations or something else. The technical challenges were substantial, but the engineering teams were confident they could be overcome, were already building and testing components, were working long hours to meet the aggressive schedule. In parallel with the mission preparations, the scientific analysis of the existing data continued and deepened. Teams of specialists were going through the spacecraft data line by line, pixel by pixel, extracting every possible piece of information, building detailed models and simulations, testing hypotheses and refining theories. The chemistry team was particularly busy, trying to understand the implications of those complex organic molecules that had been detected, trying to determine whether their formation required biological processes or could occur through purely abiotic mechanisms. They were finding that some of the molecules were indeed difficult to explain without invoking life, or at least very sophisticated catalytic processes that could organize chemical reactions in selective ways that could build complex structures from simpler precursors according to some kind of template or blueprint. The geologists and planetary scientists were struggling to understand the surface features, those channels and bright regions, and the absence of craters. They had constructed numerous models, had run computer simulations of erosion and outgassing, and ice sublimation and mechanical stress, and while they could produce some features that looked vaguely similar to what was observed, they couldn't reproduce the full complexity and organization without adding additional assumptions, without supposing that something was actively shaping and maintaining the surface structures, rather than just passively responding to external forces. The more they looked at the data, the more convinced they became that this wasn't ordinary geology, wasn't the kind of thing that happened spontaneously on small bodies in space, but rather something that required explanation beyond the standard planetary formation and evolution models. The months after the spacecraft encounters were a time of intense intellectual ferment, with ideas and theories and speculations flying in every direction, with old assumptions being challenged and new frameworks being proposed, with the boundary between mainstream science and more speculative thinking becoming somewhat fluid as researchers grappled with observations that didn't fit comfortably into existing paradigms. It was an exciting time to be working in planetary science or astrobiology or related fields, was the kind of moment that scientists dreamed of, when the universe revealed something genuinely new and unexpected, when the comfortable certainties of textbook knowledge proved inadequate and creative thinking was required to make sense of what nature was showing. The public continued to follow the story with sustained interest, unusual for an astronomical discovery, but 3I divided by Atlas had captured imaginations in a way that most scientific findings didn't, perhaps because it was so visual, so obviously strange even in photographs and images that laypeople could understand without technical expertise, or perhaps because it tapped into deep archetypal themes about visitors from distant realms, about messages from the stars, about the possibility that humanity was not alone in the universe. The object had become a cultural phenomenon, referenced in movies and television shows and novels, used as a metaphor in political speeches and philosophical essays, inspiring art and music and poetry, becoming woven into the fabric of contemporary human culture in the way that only a few scientific discoveries have managed to achieve. And all the while, 3I divided by Atlas continued its journey, moving farther from the sun each day, heading back out toward the realm of the outer planets, and eventually toward the heliopause and interstellar space beyond. Its brightness was fading as it receded, as the solar heating decreased and the outgassing slowed, as the glowing corona gradually diminished, though never quite disappeared entirely. The pulsing pattern continued, though the period kept changing slowly, gradually lengthening as if the object was relaxing after the intense activity of perihelion, returning to some kind of baseline state, preparing for the long dormancy that would characterize the next millions of years of its journey through the galaxy. The astronomers continued to watch, continued to measure and record, knowing that every observation added to the dataset, added to the body of knowledge that future generations would use to understand this remarkable visitor. The NASA Rendezvous mission launched successfully on a cold morning in early spring, the rocket's engines igniting with a roar that echoed across the coastal launch site, carrying the spacecraft and its cargo of instruments and hopes and human curiosity up through the atmosphere and into orbit and then beyond, accelerating toward an intercept trajectory that would catch up with 3I divided by Atlas in about 8 months, when the object would be somewhere beyond Jupiter's orbit, moving steadily outward, but still within range of Earth's communications, and still accessible with current propulsion technology. The spacecraft was state-of-the-art, incorporated lessons learned from decades of planetary exploration, carried instruments that represented the cutting edge of what was possible in space science, and was operated by a team that included some of the most experienced and capable mission specialists in the world. The journey out to the rendezvous was long but not uneventful. The spacecraft performed several course corrections, fine-tuning its trajectory based on updated observations of 3I divided by Atlas's position and velocity, ensuring that when the moment came for the rendezvous maneuver, everything would be perfectly aligned. The instruments were tested and calibrated during the cruise, checking that everything was functioning properly, that the data pipelines were working, that the communication systems were robust. The operations team practiced the rendezvous sequence repeatedly in simulations, rehearsing every maneuver and contingency, preparing for every scenario they could imagine and some they probably couldn't, knowing that once the spacecraft was close to 3I divided by Atlas, they would have only one chance to get things right, that any mistakes could mean losing the mission, or at minimum failing to achieve the scientific objectives that had justified the enormous investment of resources and effort. As the spacecraft approached its target, the tension in mission control built steadily. This was the most complex and risky phase of the mission, when the spacecraft would need to execute a carefully choreographed series of engine burns to match velocity with 3I divided by Atlas, to essentially transform itself from a fast-moving probe passing through the solar system into a companion orbiting alongside the interstellar visitor. The margin for error was small, the fuel budget tight, the navigation requirements exacting. But the team was ready, had done everything possible to prepare, had checked and double-checked and triple-checked every calculation and every command sequence, had contingency plans for every failure mode they could identify. They were as ready as they could be for the unknown. The rendezvous maneuver began exactly on schedule, with the spacecraft firing its main engine for a carefully timed burn that reduced its velocity relative to 3I divided by Atlas, matching the object's speed and direction, transforming itself from pursuer to companion. The burn lasted several minutes, was smooth and nominal, achieved the desired change in velocity within the narrow tolerance window. The spacecraft then executed a series of smaller thruster firings, fine adjustments that brought it into a loose orbit around 3I divided by Atlas, circling the object at a distance of several kilometers, far enough to be safe from dust and debris, but close enough for the instruments to make detailed measurements. Mission control erupted in applause and cheers when the final confirmation came through that the rendezvous was successful, that the spacecraft had achieved stable orbit, that all systems were healthy, and the mission could proceed to the next phase. The view from the spacecraft was extraordinary. High-resolution cameras pointed at 3I divided by Atlas from close range captured images with unprecedented detail, showing the surface features with such clarity that individual rocks and ice patches and dust deposits could be distinguished, showing the channel-like structures in three-dimensional relief, showing the bright regions with enough resolution to see that they weren't uniform but had internal structure, darker cores surrounded by lighter halos, connected by those fine linear features to other parts of the surface. The imagery was released to the public as it came down, and the response was immediate and intense, with millions of people viewing the images online, sharing them, commenting on them, marveling at the alien landscape that was being revealed in such intimate detail. The lander deployment was scheduled for 2 weeks after rendezvous, time enough to thoroughly map the surface and select the optimal landing site, time enough to ensure that all spacecraft systems were functioning perfectly and that the conditions were suitable for the risky maneuver. The site that was ultimately chosen was near one of the bright regions, close enough to study it directly, but not so close that the lander would be damaged by whatever processes were generating the glow and heat. The landing sequence was completely automated, with the lander separating from the main spacecraft and using small thrusters to descend slowly toward the surface, adjusting its trajectory based on real-time measurements from its altimeter and navigation cameras, aiming for a relatively flat area that looked stable and safe. The descent took nearly an hour, a slow, careful approach that gave ground controllers time to monitor every stage. Though of course by the time they saw what was happening it was already in the past. The speed of light delay, meaning that any problems would have occurred long before Earth knew about them, and any corrections would have to be made autonomously by the lander itself. But the autonomous systems worked flawlessly, navigating the lander down through the faint wisps of the corona, adjusting for unexpected air currents or density variations, compensating for the weak but non-zero gravity of the object, making tiny corrections to ensure a safe touchdown. Contact with the surface came as a gentle tap, barely felt, the lander's legs compressing slightly as they absorbed the impact energy, and then stillness, and then confirmation flowing back through the telemetry that the landing had been successful, that all systems were nominal, that humanity had placed an instrument package on the surface of an object that had come from another star system, had physically touched something that had journeyed across the galaxy. The lander immediately began its science program, deploying instruments and making measurements, analyzing the surface composition and temperature and mechanical properties, measuring the local magnetic field and radiation environment, taking photographs of its surroundings from this new perspective. The surface turned out to be surprisingly firm, not the soft, fluffy snow that a water ice comet might have, but rather a harder crust. Still mostly ice, but compressed and sintered by some process into a material with mechanical strength. The temperature was cold, of course, far below the freezing point of water, but not as cold as it would be in deep space, suggesting that internal heat was indeed reaching the surface, was warming it from below in a way that no purely solar-heated object should exhibit at this distance from the Sunday. The lander's drill began its work, attempting to collect a sample from beneath the surface crust, pushing its bits slowly into the material while monitoring the resistance and adjusting its speed and pressure accordingly. The drilling went smoothly for the first few centimeters, but then the bit encountered something unusual. A layer of different material that was harder than the ice above, that required more force to penetrate. The drill was designed to handle varying hardness, had multiple cutting surfaces and variable speed controls, and it managed to push through this hard layer and continue downward. But the unexpected resistance was noted and analyzed, added to the growing list of things about 3I divided by Atlas that didn't match standard comet models. When the drill finally brought up its sample and delivered it to the lander's analysis chamber, the results were startling even to scientists who thought they had prepared themselves for anything. The sample contained all the expected components: water, ice, carbon dioxide, simple organics, but it also contained structures that looked under the microscope like they had organization, like they had been assembled rather than just randomly deposited. There were filaments, thin strands of organic material that connected particles together in networks that looked disturbingly like primitive biological structures, like the kinds of things that on Earth would be cellular walls or scaffolding, or the support structures that bacteria use to form colonies. The filaments were too small and too fragile to extract intact, kept breaking when the manipulator arms tried to isolate them for more detailed study, but the images were clear enough to show their existence, to document their presence, to provide evidence that was difficult to explain through purely abiotic chemistry. The discovery of these filamentous structures triggered another wave of intense debate and discussion within the scientific community. Were these biological in origin, Or could they be some kind of exotic mineral or polymer that formed under the unusual conditions of interstellar space? The lander's instruments weren't designed to definitively determine whether something was alive or had once been alive. Couldn't do DNA sequencing or metabolic measurements or the kinds of tests that biologists would use to characterize terrestrial organisms. They could measure chemical composition and physical structure, but not the more subtle markers of life, not the complex organization and information processing that distinguish living systems from complex chemistry. So the question remained open, remained tantalizingly unanswered, despite the remarkable data that was flowing back from the surface. The lander continued its operations for several weeks, measuring and sampling and photographing, gradually building up a detailed characterization of that one small patch of 3I divided by Atlas's surface, while the orbiting spacecraft maintained its watch from above, continuing to map and monitor and measure the global properties of the object. The two components of the mission complemented each other perfectly. The orbital data providing context and overview, while the lander data provided detail and ground truth, together creating a comprehensive dataset that exceeded the most optimistic pre-mission expectations. And then, 43 days after the lander touched down, something remarkable happened. The bright region near the landing site, which had been relatively quiet and stable throughout the lander's operation, suddenly activated, began glowing much more intensely than it had at any time since perihelion, began pulsing at a rapid frequency that was different from the usual pattern, began displaying what looked like a response to the lander's presence. The instruments recorded a spike in temperature, a surge in particle emission, a rapid change in the magnetic field configuration, all happening within the space of a few minutes, all clearly linked to the bright region's activation. And then, most remarkably, the lander itself registered something unexpected, a vibration, a rhythmic mechanical disturbance propagating through the surface material, coming from the direction of the bright region, a pattern of pulses that occurred at regular intervals, that repeated several times before fading away and leaving the region quiet again, returning to its previous dimmer state. The mission team was stunned. They had hoped for interesting data, had expected surprises given how unusual 3I divided by Atlas had proven to be, but this was beyond anything they had anticipated. The vibrations could be felt by the lander's seismometer, were strong enough to be clearly detected, were definitely not random thermal noise or instrument artifacts, but real mechanical waves traveling through the object's interior. And the pattern, when they analyzed it carefully, showed structure, showed what looked like modulation, like something that was varying deliberately rather than just randomly fluctuating. Could it be some kind of signal? Could whatever was inside, or was 3I divided by Atlas itself, be trying to communicate, be responding to the presence of the lander, be acknowledging that it had detected the human-made instruments sitting on its surface? The possibility that they were witnessing attempted communication was both thrilling and deeply unsettling. If 3I divided by Atlas was indeed sending a signal, if something about it was capable of detecting the lander and formulating a response, then the implications were profound and far-reaching. It would suggest not just complex chemistry or even simple life, but something with sensory capabilities and information processing, and perhaps even something like intelligence, something that could perceive its environment and react to it in purposeful ways. The analysis of the vibration pattern became the focus of intense effort, with experts in signal processing and information theory and linguistics all brought in to study the data, to try to determine whether there was meaningful content in the pattern, or whether it was just a natural response to mechanical disturbance, like an echo or a resonance phenomenon. The analysts found patterns within patterns, found regularities and repetitions that suggested structure that looked like the pattern contained information, though they couldn't decipher what that information might be. The vibrations occurred in groups, with varying numbers of pulses per group and varying intervals between groups, creating what looked like it could be a code or a language, or at least some kind of structured message. But without context, without knowing what the patterns meant, or even whether they meant anything, decipherment was nearly impossible. It was like finding an ancient text written in an unknown language with no translation key, knowing that information was likely present, but having no way to access it, no way to bridge the gap between data and meaning. The decision was made to attempt a response, to see whether the lander could send a signal back and whether 3I divided by Atlas would react. This was controversial, raised concerns about planetary protection and the risks of further interaction with something that was so poorly understood, but ultimately the scientific leadership decided that the potential benefits outweighed the risks, that attempting communication could provide crucial insights that might not be obtainable any other way. The response was designed to be simple and clear, using the lander's vibration generators to tap out a pattern that mirrored what had been received, a basic echo that would demonstrate that the vibrations had been detected and understood as intentional, that would open a channel for potential further exchange. The response was transmitted, a series of mechanical pulses sent through the surface material toward the bright region, carefully timed and sequenced to match the pattern that had been received. And then everyone waited, watching the instruments, monitoring for any reaction, hoping for something but not knowing what that something might be. Minutes passed, then hours, with no obvious response, no change in the bright region's activity, no new vibrations detected. The team began to think that perhaps the attempt had failed, that either the message hadn't been received, or hadn't been recognized, or had been ignored, that maybe they were reading too much into what was ultimately just a natural phenomenon. But then, nearly 6 hours after the response was sent, the bright region activated again, more intensely than before, and the seismometer registered a new pattern of vibrations, different from the first set, but clearly related, clearly intentional, clearly responding to the lander's message. This new pattern was longer and more complex, contained more information, or at least more structure, seemed to be elaborating on the initial exchange, building something, perhaps trying to establish common ground or shared symbols, or some basis for more sophisticated communication. The analysis teams worked feverishly, comparing the new pattern to the old, looking for relationships and transformations, and rules that might govern how the patterns changed, trying to extract meaning from pure structure. Over the following days and weeks, the exchange continued, with the lander sending patterns and 3I divided by Atlas responding, each response slightly different from the previous ones, each one adding new elements or variations or complexities. The humans were learning how to communicate with something that wasn't human, or at least they were learning the beginnings of that process, learning what kinds of patterns elicited responses and what kinds were ignored, learning what modifications to their messages produced, what changes in the replies. It was slow and frustrating and exhilarating, was exactly the kind of first contact scenario that SETI researchers had theorized about for decades, but never expected to actually experience, and certainly not from an object that had appeared to be a comet, that had no obvious features suggesting intelligence or technology until humans looked closely enough to see beneath the surface. The revelation that 3I divided by Atlas might be communicating, might be aware, might be something that could be considered intelligent in some sense, transformed the entire context of the mission and of humanity's relationship with the object. This wasn't just a scientific curiosity anymore, wasn't just an interesting puzzle for astronomers and chemists to work on. If 3I divided by Atlas had some form of intelligence, then ethical considerations became paramount. Did it have rights? Should humanity be studying it, or should they be treating it as a fellow conscious being, deserving of respect and autonomy? Was the lander's presence on its surface an intrusion, a violation, something that would be considered aggressive or harmful by whatever passed for 3I divided by Atlas's value system? These weren't questions that had clear answers, weren't questions that existing ethical frameworks had been designed to address, because they involved a type of situation that had never occurred before in human experience. The philosophical and ethical debates played out in academic journals and conference panels and public forums, with people from diverse backgrounds and perspectives weighing in on what the appropriate response should be. Some argued for caution and restraint, for pulling back the lander and ending the communication attempts until there was better understanding of what 3I divided by Atlas was and what it wanted. Others argued for continued engagement, for pushing forward with the communication efforts because that was the only way to gain understanding, because withdrawal might itself be interpreted as hostile or threatening by whatever intelligence existed within the object. Still others questioned whether 3I divided by Atlas really had intelligence in any meaningful sense, argued that what looked like communication might be just complex reactive behavior, sophisticated stimulus response patterns that mimicked intelligence without actually involving consciousness or understanding or intent. The truth was that no one knew, that the data was compatible with multiple interpretations, that the situation was genuinely unprecedented and genuinely ambiguous. And in the face of that ambiguity, humanity did what it had always done when confronted with mystery, continued to observe and question and wonder, continued to gather more information while debating endlessly about what that information meant and what should be done about it. The mission continued, the lander continued its operations, the communication attempts continued, though with increased attention to ethical considerations and with protocols designed to minimize any potential harm or offense. As more data accumulated, a picture began to emerge, though it was fragmentary and uncertain and subject to constant revision as new findings came in. The picture suggested that 3I divided by Atlas might be something like a frozen ecosystem, a community of perhaps biological entities that had evolved or been assembled in another star system and had survived the long interstellar journey in a dormant or semi-dormant state, preserved by the extreme cold and the lack of environmental perturbations. The bright regions might be nodes where these entities were concentrated, where they maintained some level of activity even in the deep cold, where they generated the observed light and heat through metabolic processes, or perhaps through some other mechanism that human science didn't yet understand. The network of channels connecting the bright regions might serve to distribute resources or energy or information, might be how the system maintained coherence and organization across the object's surface and interior, might be what allowed it to function as a unified entity rather than just a collection of separate components. This interpretation, if correct, would make 3I divided by Atlas the most significant biological discovery in human history, would confirm that life could exist in forms and environments radically different from anything found on Earth, would demonstrate that biology was not confined to planetary surfaces and oceans, but could adapt to the harshest conditions imaginable, could find ways to persist and even thrive in the void between stars. And if the communication attempts were indeed real exchanges with something intelligent, if there was consciousness somewhere in that frozen network, then it would also represent the first contact between humanity and another intelligent species, would mark a before and after moment in human history, comparable to the invention of writing or the scientific revolution or any of the other transformative developments that had shaped the human story. But all of this remained speculative, remained provisional, remained subject to being overturned by the next observation or the next analysis. The scientific process continued, grinding slowly toward understanding, building up certainty one data point at a time, testing hypotheses against evidence and discarding those that failed to match reality. The mission was scheduled to continue for another year at least, possibly longer if the spacecraft remained healthy and funding continued, giving the teams time to conduct more experiments, to refine their communication protocols, to perhaps eventually achieve something like a mutual understanding with whatever 3I divided by Atlas was or contained. The object itself continued its outward journey, was now well beyond Jupiter's orbit and still moving, still heading toward the outer reaches of the solar system and eventually toward the heliopause and interstellar space. At some point, probably within a few years, it would pass beyond the range where communication with Earth was practical, where the time delays would become so long and the signals so weak that maintaining contact with the spacecraft would no longer be possible. And then 3I divided by Atlas would be on its own again, would return to the cosmic solitude it had known for hundreds of millions of years, carrying with it whatever memories or records it might have of this brief encounter with humanity, this moment when it had passed through another star system and been noticed and studied and perhaps communicated with by beings who were themselves struggling to understand their place in the vastness of space and time. For humanity, the encounter with 3I divided by Atlas would be remembered as a pivotal moment, as the time when it became clear that Earth was not isolated, that the galaxy was full of wonders and perhaps full of life, that the universe was stranger and more alive than our ancestors had imagined when they looked up at the night sky and wondered what those points of light might be. The scientific knowledge gained from the mission would be important, would advance understanding of chemistry and biology and planetary science in ways that would take decades to fully appreciate. But perhaps more important was what the encounter did to the collective human imagination, how it shifted perspective, how it made people think differently about who they were and where they came from, and what possibilities existed beyond the familiar boundaries of Earth and the solar system. The image of 3I divided by Atlas glowing against the darkness, pulsing with its mysterious rhythm, would become iconic, would join the small collection of images that defined how humanity saw itself and its cosmic context, the Earth rising above the lunar horizon, the pale blue dot in the vastness of space, the pillars of creation where new stars were being born. And now this strange visitor from another system, this bearer of complexity, and perhaps of life, and perhaps even of consciousness, this reminder that the universe was full of questions waiting to be asked, and full of answers waiting to be discovered. And so the story continues to unfold as the mission proceeds, as the data accumulates, as the analyses become more refined and the theories become more sophisticated, and the understanding deepens. The questions that drove the initial observations remain relevant. What is 3I divided by Atlas? Where did it come from? What does it mean? But they have been joined by new questions, richer questions, questions about consciousness and communication and the nature of life in its most extreme manifestations. These questions will occupy scientists and philosophers for years or decades to come, will inspire new missions and new technologies and new ways of thinking about the cosmos and humanity's place within it. The encounter also prompted reflection on humanity's readiness for contact with other intelligences, on whether our philosophical and ethical frameworks were adequate to guide interactions with beings that might be fundamentally different from us in origin and nature and capabilities. The debates about how to communicate with 3I divided by Atlas, about what messages to send and whether to send any at all, revealed deep uncertainties about values and priorities, about what humanity stood for and what it wanted to represent to the universe. These debates were healthy and necessary, were part of the process of growing up as a species, of moving beyond the childhood phase where Earth was everything and the sky was just a decoration overhead, into a more mature phase where humanity recognized itself as one voice among potentially many, one perspective in a cosmos that might be full of perspectives. Looking back from some future vantage point, historians might identify the discovery of 3I divided by Atlas as a turning point, as the moment when humanity truly began to think of itself as part of a galactic community, when the search for extraterrestrial life and intelligence moved from the realm of speculation into the realm of actual encounter and engagement. Or perhaps they will see it as just one more step in a longer journey, a significant step but not uniquely so, one discovery among many that gradually accumulated to shift understanding and perspective. Either way, the encounter mattered, meant something, contributed to the ongoing human project of understanding and exploring and finding meaning in the vast and ancient universe that was our home, The light from 3I divided by Atlas continues to pulse even now as these words are written, continues its ancient rhythm as the object moves through the outer solar system, that steady heartbeat in the dark that first caught the attention of astronomers and sparked this entire chain of discovery and wonder. That light has been traveling for hundreds of millions of years, has witnessed the rise and fall of countless species on Earth, has been present through ice ages and warm periods, through extinctions and evolutionary radiations, through all the changes that transformed Earth from one kind of world into another, and finally into the world that could build telescopes and spacecraft and reach out to touch the mystery that fell through its. And when 3I divided by Atlas finally leaves the solar system, when it crosses back into interstellar space and resumes its galactic journey, it will carry with it the knowledge of this encounter, will bear the marks of humanity's presence, the lander sitting on its surface as a monument to curiosity and courage and the desire to understand. Perhaps millions of years from now, when 3I divided by Atlas passes through another star system, other beings will find that lander, will study it and wonder about the creatures who built it. They will try to reconstruct what they were like and what they thought and what motivated them to send their instruments across space to land on this wandering object. And perhaps those future finders will recognize something of themselves in what they discover, will see in humanity's curiosity and creativity and yearning for connection a mirror of their own nature, will understand across the gulf of time and space and biological difference that there are certain qualities that might be universal wherever consciousness arises, wherever beings capable of wonder look up at their sky and ask what lies beyond. This is what 3I divided by Atlas has given us, not just scientific data and evidence of exotic chemistry and possibly life and possibly intelligence, but also a story, a narrative that connects past and future, that links humanity to the broader cosmic context, that reminds us that we are part of something much larger than ourselves, much older than our civilization, much stranger and more wonderful than our theories and models can fully capture. The pulsing light that began this story continues still, continues to call out across the void, continues to invite attention and inquiry and wonder, continues to ask without words the questions that matter most. What are we? What is possible? What mysteries wait in the darkness between the stars? The image wasn't supposed to look like this, we said at the beginning, and that remains true, remains the fundamental mystery at the heart of this encounter. But perhaps the deeper truth is that we never really know what anything is supposed to look like, that our expectations and models are always provisional, always subject to revision when nature reveals something new, always inadequate to capture the full richness and complexity of what actually exists. 3I divided by Atlas looked wrong because it challenged our assumptions, because it exceeded our categories, because it was genuinely new and genuinely other and genuinely mysterious in ways that demanded attention and respect and humility. And so we watch and we wonder and we wait to see what else might fall through our sky, what other visitors might arrive from the vast dark, what other mysteries might present themselves to our instruments and our curiosity. The universe has shown us that it is full of surprises, full of things we didn't expect and couldn't have predicted, full of invitations to look deeper and think more carefully and imagine more broadly. 3I divided by Atlas was one such invitation, one such surprise, one such reminder that the cosmic story is still being written and that humanity has the privilege of reading some of its chapters and perhaps even contributing a few words to its endless unfolding narrative. The latest image changed everything because it showed us that everything could change, that the universe was not finished surprising us, that there were still wonders waiting to be discovered, and experiences waiting to be had, and questions waiting to be asked. And in showing us that, it gave us perhaps the greatest gift that any discovery can give: hope, wonder, and the certainty that the journey of exploration and understanding has no end, that there will always be new horizons to reach toward, new mysteries to pursue, new light pulsing in the darkness, waiting for those with eyes to see and minds to comprehend and hearts open to the possibility of beauty and strangeness and meaning in the infinite night.